Hi class, this is Dr. Karsten, and today we are doing lesson 10 of module 5, grade 4. And in today's lesson, we are going to be using the area model and division to show equivalence of two fractions. So we're basically going to be building on yesterday's lesson, and we're just going to take it one little step forward. So to do a quick review, I want to go over fractional units and a larger fractional unit versus a smaller fractional unit. Because we've been using division starting yesterday, we've been creating larger fractional units. So let's take a look at these two examples that I have ready to go for us. These are both about the same size, and this one I have split into fourths or divided into fourths, and you know that because my denominator is 4, so I have 4 pieces that make up the whole. So the denominator, and the way I want to start talking about it, is the total number of units, or the total number of pieces. Now in this one, my denominator is 2, so my total number of units is 2. My total number of pieces is 2. And here you can see that this piece, this shaded area, is a lot bigger than here. So when I have 1/4, when my denominator is larger, each of my units, each of my pieces or parts is smaller. When my denominator is a smaller number, 2 is smaller than 4, then each of my pieces is going to be a lot larger. Think about it like this. If you had a cake and you were going to share it with your friends, if you were just sharing it with one friend, each of you is going to get half a cake. That's a pretty big slice of cake. If you're sharing it with 10 friends, or let's say 9 friends, so there's 10 of you in total, each of you is going to get 1/10. You're going to get a lot smaller piece. Or if I had an apple and I cut it in half, each of those pieces is pretty big. If I cut an apple into 4 slices, then each of those slices is a lot smaller. So the more slices you make, the smaller each of those pieces. So when your denominator is bigger, each of your units or each of your parts is going to be smaller. When your denominator is a smaller number, like 2 or 1, then each of your pieces is going to be a lot larger. And again, those pieces are going to be our fractional units. And today we want to make large fractional units. We want to try and get our pieces as big as possible. So when we're doing division, that's what we're doing. We're making larger fractional units. So again, for another quick review from yesterday, so here's an example, a typical example of what we did yesterday. And yesterday was nice and easy because if I wanted to make larger fractional units, I could just go ahead and we were just simply circling our columns. So here I have 2/6. The way I know that is that 6 is the total number of units. That's my denominator. It's the number of parts or pieces that the whole thing is broken up into. 1, 2, 3, 4, 5, 6. And in this case, my numerator is 2. And that's because that's the number that is shaded or the number that I have. So yesterday what we did was we said, oh, well, let's circle our columns. So here we had 1 column, 2 columns, 3 columns. So now I've made it from 6 groups into 3 groups. And I have 3 groups of 2. We could just count the number of rows that were in each of our columns. So the way that we would have modeled that yesterday, or divided that, was, remember, we would have written our original fraction, 2/6, and then we would have shown what we were dividing by, which is the number of rows that we had. So if I do that, I would divide by 2, and then that would show us how many groupings we now had. So we had 1, and here this became 3. So you can see we have 3 groups, and then those are our larger fractional units, and one of them is shaded. This would be one group, and it is shaded, so that's why our numerator is 1. So this is what we did yesterday. Today, though, we're going to take it up a notch, because we are not going to simply be taking our columns. We're not necessarily going to be always dividing by the numerator. And I don't know if you noticed that yesterday, but in all our problems, when we were simply circling our columns, we were always dividing by whatever the numerator was, and we were turning it into a unit fraction. Today, we're not always going to have unit fractions. So that's where the difference is going to be, is we're going to have to figure out different numbers that we could possibly divide by, different factors we could divide by. And I'm hoping that all of you are remembering our factors from Module 4 and when we were able to list the factors of a number. So one more super quick review before we get into today's problems. Let's say that I had the number 12. And I wanted to figure out what are all the factors of 12. And I'm going to slide that over a little for us so it's more clear. So if I wanted to do that, I could say 1 works, and that would be 1 times 12. So 1 and 12 are factors. Then I'm going to try 2, and 2 works. 2 times 6. I'm going to try 3. 3 times 4. I'm going to try 4. Oh, I already wrote 4. I'm done. I've looped around. And remember, that's the way that we've been doing it. Let's try one more example. Let us try 10. And you'll know why I'm using these numbers in a second. So I'm going to try 1. 1 and 10 works. Does 2 work? Yes. 2 and 5. Does 3 work? Nope. 10 is not divisible by 3. Does 4 work? Nope. 10 is not divisible by 4. Does 5 work? Yes. But I've looped around. Once I come over here to this column with my numbers, you know you're done. So this was like a way for us to make sure that we always found all of our factors. So let's go into our problems for today, and let's see how they're a little different. Now, I'm going to just really quickly shut off the light in my house so that you don't get these reflections, because I need to use this sheet for our first example. Okay, so I apologize that it's kind of a little dark, but I think we'll manage. So if I wanted, well, let's first take a look at this. So let's figure out what fractional part we have here. So let's count the total number of fractional units. How many units do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that our denominator is going to be 12. So I'm going to go ahead and write that right here. And let's figure out what our numerator is going to be for this one. And it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want to turn these into larger pieces, larger fractional units. Remember how we talked about 1/2 is a larger fractional unit than 1/4? So I'm going to be dividing. So I'm going to try and figure out different ways that I can circle these where I have no remainders or no leftovers. So all my circles have to have a complete number of shaded parts in them and unshaded parts in them. So some of you guys are probably saying, well, Dr. Karsten, I can see that I have 2 there. Just humor me. Let's go with this. So I can't divide by 10 because I know that 10 is not a factor of 12 because we just did that before, and I know it's definitely not. But let's see, can I maybe do groups of 4? So if I divided this into groups of 4, there's 1 group of 4, there's 2 groups of 4, and now I get stuck. This would not be a group of 4 where it was either all shaded or all unshaded. I cannot do that. So let's try again, and now you see why I'm using this today. Okay, let's do groups of 3. So if I did a group of 3 here and a group of 3 here, and I know this is a little wonky, but I could do a group of 3 there, but then my last group of 3 is going to have a shaded piece and 2 unshaded. That is definitely not going to work for us. Let us try 2, and let's see if 2 works for us. So we could do 1, 2, 3, 4, 5 groups of 2 that are shaded, and then we would have 1 more group that is unshaded. That worked. And the way that then I could write that for us, the equation, is going to be exactly how we did it yesterday. So I'm going to start with my original fraction. Then we're going to show how we turned it into our new fraction. So let's just go ahead first and write our new fraction. We have 1, 2, 3, 4, 5, 6 groups now as my denominator. So that's the total number of units. And then in the numerator, we're going to have the shaded. 1, 2, 3, 4, 5. And now again, we just copy over what we're starting with because we have to show what we did with it. And in this case, the number of pieces or parts that is in each of these groups was 2. We divided it into groups of 2. So we're dividing both by 2. There's 2 in here, 2 in there, 2 in there. And that's how we got to 5, 6. 10 divided by 2 is 5. 12 divided by 2 is 6. This is the basic idea of what we're doing today, is that we're not simply going to grab the numerator and divide by the numerator. Can't do that for this one. And that we can try different sized groups. Now, I personally do not want to have to do a whole bunch of different sized groups and do all this trial and error. You guys don't have one of these nice sheets that you can put over your paper so that you can do trial and error. There is another way, and that is that we can use factors. So for this, for example, I could have just looked at those factors that we did before and figured out what was the largest common factor that I could have used. So let me kind of go over that really quick again with this exact problem. And I'm sorry that we're running out of space here because I was writing so large. But the factors that we found for 12 and 10, for 10, our factors from before were 1, 2, 5, and 10. And for 12, they were 1, 2, 3, 4, 6, and 12. So if I look at this, they don't have these larger numbers in common, these larger factors in common. The one that they have in common was 2. They always have 1 in common, but 2. So that is why we could have right away known that we could have divided both the numerator and denominator by 2. Okay, let's do another example like that. Now I can go back to my regular paper, so I'm going to go and click on the light again. Okay, and it's like magic. I was able to make that disappear. So lights are back on. Let's take a look at using the factors again really quickly, just so you really understand it. So let's say that I wanted to take 6/10. Ooh, I feel like my hand was just super huge. I feel like I'm not lined up here very well. So let's say that I was taking 6/10, and I wanted to rename that into larger fractional units. Now, we are going to be using the area model for a lot of these, but it might be easier if we also kind of looked at those factors. So let's take 6, and let's look at the factors of 6. Now remember how I like to do this. I make my little column, so I say that I know that 1 times 6 works. I know that 2 times 3 works. 4, nope, doesn't work. It's not a factor of 6. 5 doesn't work. But anyway, once I got to 3, I knew I was done because I looped. So 1 times 6, 2 times 3, and 3 is already here, so I'm done. Let's look for the factors of 10. So 1 times 10. Oop, the sun's coming out for us. Sorry, guys. I might have to move over. 2 times 5 works. Does 3 work? No, 3 does not work. Does 4 work? No, 4 does not work. Does 5 work? Yes, 5 works, and it's right there, and it is, we have now looped. So we have all our factors. I'm going to pause this and move myself into the shade. Okay, so here we go. I think you can see better now. I just had to slide over a bit. What's great is that we do have the outdoor sunlight coming in today, but it hit us wrong, and I can actually put on my light again. There we go. Okay, so again, we are trying to rename 6/10 into larger fractional units. So the first thing that I wanted to do, since I didn't want to just jump into the area model and start circling things, was I wanted to go ahead and see what are all the factors of 6 and what are all the factors of 10, and then what is the greatest common factor that they have. So let's take a look, and I'm going to go ahead and list these because sometimes it's easier for some people to see it that way. So for 6, we had 1, 2, 3, and 6, and for 10, we had 1, 2, 5, and 10. And something that you should notice with this is that once again, 2 is a common factor. 1 is a common factor. 1 will always be a common factor. But here we have 2. I have nothing larger than 2, so 2 is my greatest common factor. So now what I know is that if I just wanted to do this mathematically, and I'm sorry that I don't have the whole page here, but I want to try and keep the numbers large. If I were to now write this, I could say that 6/10 can be renamed into a larger fractional unit by taking that 6/10 and dividing it by the largest common factor, 2, in which case 6 divided by 2 is 3, 10 divided by 2 is 5. So now let's go ahead and let's see if we can draw that area model and make that work for us. So let me start. I think we're good. So I'm going to go ahead and I am going to draw 6/10. So the first thing I need to do is figure out how I'm going to make tenths, and this is a little bit small, I apologize. So let's see if I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do. Now I have to shade in 6 of those for my numerator. So there's 2, 4, 6. Okay, so I have 1, 2, 3, 4, 5, 6. So we're good. And now let's model making groups of 2. So here's 1 group of 2, 2 groups of 2, 3 groups of 2. So that's when you're dividing. You're just making groups of whatever you're dividing by, whatever factor you're using. And now you can see that I have 1, 2, 3 groups that are shaded. And I have 1, 2, 3, 4, 5, which is the total number. Oh, I didn't circle these last 2, of units, of fractional units that we have going on. So here you can see that, and you know, I want to just draw this actually for those of you who it might be easier. I'm going to redraw this to match, because I think that might be easier for some people. Oh, and I just totally messed that up. So let me redraw this in the new way. So for now, what we have is, instead of having 10 groups, or 10 units in total, we have 5, that's the circles, and then 3 of them are shaded. And you can see how this matches. So you can see how these match. So this would be doing it a slightly different way, because what we did was, instead of showing it immediately using an area model, we did it mathematically by finding the common factors and picking the largest one. And then we showed that what we did by drawing it out and modeling it. So we had 6/10, and we divided it or grouped it into groups of 2 to make 3/5, which is a larger fractional unit. Okay, so I think, oh, I wanted to show you one more example. So let me show you one more example, and then we're going to jump into the problem set. Now, what's really great is that we have done so many examples today that we don't have to do a whole lot of the problem set together. But let's take a look at comparing. Let's say I want to turn 8/12 into larger fractional units. So I wonder how many different ways I could do this. So we can draw it, or we can go ahead and we can do it mathematically. So we're going to do it both ways. I want to again emphasize this idea of using factors, so we're going to start there. So let's find all the factors of 8, and let's find all the factors of 12. So for 8, I have 1 and 8. 1 times 8 is 8. 2 times 4 is 8. Does 3 work? No. Does 4 work? Yes, but I already wrote it down, so I've looped. I'm good. So I can write that. The factors of 8 are 1, 2, 4, and 8. Now for 12, I have 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Does 4 work? Yes, 4 works. But I've looped, so I'm done. So again, 1 works, 2 works, 3 works, 4 works, but it's in this column. So I know I've found all my factors already. So I'm going to go ahead and write that as well. So we have 1, 2, 3, 4, 6, and 12. Again, 1 is always a common factor, but we have 2, and we have 4. So let's try both using 2 and 4 and see what happens to our fractional units. And I need to pause you guys for 1 second. I have to go get my kids. I will be right back. Alright, so I am back. I just had to get my kids going. And actually, I am running out of time. So I'm going to finish up this part, and then I will post some examples from the problem set later today. I'm just going to finish out this problem because I need to run up to the school really quick. So what we were doing again was we looked for a common factor, the greatest common factor, that 8 and 12 would have. So let's go ahead and really quickly model what we just did and see how that looks. And actually, I'm going to go ahead and try and make this have more of the page so that we can see everything. It's just that then the numbers get a lot smaller. But let's see if this can work. So I'm going to model it 2 different ways. So let's go ahead and really quickly sketch out 8/12. Oh no, and the sun's creeping closer too. And we're going to do it twice. And one time we are going to make groups of 2 because we're dividing by 2. Another time we're going to make groups of 4 because we are dividing by 4. So let me go ahead and I'm just trying to think about the best way to do this. Sorry, I'm rushing a little bit. So my drawings are a little less accurate than I normally would do. But that's okay. Pretend they're all equally sized groups. And again, I have to shade in 8 of them. So I'm going to go ahead and shade in these. And I'm going to shade them in over here too. So each of these is representing 8/12. And you know that because for both of these, I have 8 is the total number of units. 12 is the total number of units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I have 8 in my numerator, so 8 of them are what is shaded. 1, 2, 3, 4, 5, 6, 7, 8. Now let's model making groups of 2. So I'm going to circle groups of 2. So I have 1, 2, 3, 4, 5, 6. And here let's do groups of 4. So we have 1, 2, 3. So it worked out perfectly. I have no remainders. All my groups are filled with either shaded or unshaded, so everything looks good. And what you can see is that each one of these groups has 4 pieces in it here. This is a lot bigger than this. So you can see that this is larger. So when we divide by the larger factor, each one of our fractional units becomes larger, which means that the denominator is smaller. So for this one, my denominator is the total number of groups, 1, 2, 3, or the total number of units, so I have 3. And what fraction of them is shaded? 1, 2. Over here, my total number of groups is 1, 2, 3, 4, 5, 6, and 4 of them are shaded. Here my denominator is smaller, so each one of my groups is larger. Each piece is larger. Remember that from the very first example that I did. Over here, my denominator is 6, so each of the groups is smaller. And again, I could have also modeled this with division. So let me start off here. I started off with 8/12. And then what we did was we divided the numerator and the denominator by 4. And we ended up with 2/3. Whereas over here, we started with 8/12. And we divided the numerator and denominator by 4. And remember, when you're dividing by the same number, it's really just dividing by 1. We've covered that. You can go back to previous things. Oh, I'm going to put my equal sign here. And we ended up with 4. Oh, I totally just messed this up. I am so sorry, guys. Let me rewrite that. We didn't divide by 4. And again, you shouldn't rush, but I do need to run for a few minutes. Here we made groups of 2, so we divided by 2. And that left me with 4/6. 8 divided by 2 is 4, 12 divided by 2 is 6. Okay, so I am going to process this, upload it so you have it. We are going to be doing the problem set from this lesson, from lesson 10. So I will post this video for you, and then I'll come back and I'll model a few of the problem set problems for you. I know this was a long one, but I really wanted you to understand the concept. I want to take you from soup to nuts with it, from beginning to end. So I hope this makes sense, and I will see you guys in our Google Classroom shortly.